The paper recycling industry collects waste paper for popping to produce another cycle of usable paper. However, after 6 times cycles of repopping, the cellulose fiber will be too short to reuse. Our research proposes an alternative production system whereby bales of paper destined for the landfill are repurposed into bricks that are used within an existing construction industry context and the logging industry. Our research starts as turning paper into bricks. The bricks are made of compressed recycled paper. They have varying sizes, and the production processes involves the integration of machinery used in the paper recycling industry, as well as variations of blocks that involve more low-tech processes. Different techniques were tested on paper, involving shredding, rolling, folding, binding. Shredding of the material enables the fibers to bond together more thoroughly, resulting in the highest strength and durability of the resulting brick. Layering the material gives a distinct surface texture. Rolling the material gives a paper that can be adjusted depending on how much paper is used in each roll. The folding of the material offers small variation in surface patterning and acts as a visual reminder of the complex folding process. The variation in patterning was tested with different thicknesses and colors. The resulting surface texture are imitating this material's predecessor, wood. The bricks were tested under compression mechanically in the lab to detect stiffness. Results showed that strength is over 25 Newton square millimeter, which is the compression strength of average clay brick. We tested binding the paper with different amounts of PVA, gloss wax, jessamine, and plaster. If enough compression is provided with, a binder is not necessary. We produced iterations of the pattern by using different paper grades: low-grade mixed paper, de-inking grade newspaper, office paper, craft grade unbleached packing, and high-grade print cut-off paper. To rationalize the paper behavior for pattern design, the digital simulation was carried out. We compressed various sizes of rolled paper within the same mold with the same amount of the compression each time. The simulation allowed for this design for a more complex layout. For a folding system, it starts pressing the 2D polylines based on the real press from the top. The polylines were sheathed with pressure with a ratio of 40%. Further methods of folding were tested, including inserting rolls in folding paper, folding in a different direction and with various widths. The digital simulation resulted in a variation of outcomes. The fabrication process can be driven by the digital result. For the rolling system, we tested this digital process to produce panels. For the folding system, the paper with different width and length is folded and compressed to generate the brick with a 3-dimensional texture and rippled pattern. In response to Haringey community's call for a pavilion to serve the local artists, Paper House proposal is to be constructed entirely out of local reclaimed paper and timber. The paper bricks, blocks, lodge bales, and the recycling standard bales are connected with a cable tie. Then, to create a larger rigid column structure supporting a larger roof made of reclaimed timber joists. The composition of paper bale and block creates a multi-purpose space capable of hosting different kinds of gatherings as a market space or artist workshop. The proposal is an eco-village that looks at wider environmental issues with global recycling of wood-based products. In Lemazeri Island, Finland, timber is a key part of their local economy. Our project investigates forestry's overmanagement and monoculture. Our proposal allows some of the harvested land to lay fallow for spontaneous natural growth and installation of permanent and temporary architecture. Our proposal questions if architecture and human inhabitation can be a part of this diversification of land use in Finland's popping and logging industry. Timber harvested here are made into pulp, paper, and wood construction. The idea is to use every part of the tree. To build our eco-village, we use not only locally cultivated stalks, we also use paper pulp at the end of its useful life in the city and cannot be recycled anymore. Different materials will play different roles. The wood will be used in the exterior, and paper can act as the structural material in the interior. Also, similar to the plywood, the veneer can be compressed to protect the paper as the filler. It can be considered as a new material structure with the transition between materials as an architectural language and design feature. The material transitions exist at various scales, geometry, and assembly. Drawing reference from patterns formed from wood grain, the surface pattern of the paper brick combined with timber can be a key part of the design language. The timber is bent to follow the patterns of the brick and gradually reduces in thicknesses. Also, the pattern from the facade can be extended into the building to form the various spaces with paper bricks and wood. The architectural proposal is based around the use of recycled paper and local logging material. These materials drive the design. We present Lamaziri Island with an eco-village that contributes positively to the local economy by working and caring for the natural and industrial processes in our environment.